for a little bit of background, at HashiCorp now 3 years. I am a channel solutions engineer, so I'm not actually an engineer or coder as much anymore, but that's really at the core of me. So also, and one of the reasons I've done this and taken so long to do this is that I'm exceedingly lazy at heart, right? When it comes to memorizing CLI commands and reinstalling kind of bulky binaries, I like to minimize everything. So yeah, I actually have built this together over about the last 2 or 3 years, kind of in various stages, and finally get the opportunity to present, which is fun.
Well, I'm going to let you take it away,
Great.
and I'm really looking forward to seeing. So,
Thank you. Great. So yes, John Boero. Again, I'm from the States. I'm originally from Chicago. I live just southwest London near Wimbledon now. So I've been working with HashiCorp, covering our partners in EMEA for almost 2 years now, and as a customer-facing SE for the year before that. And this is a project, again, has been open source for a while. I've been on GitHub, and if you're not familiar with Fuse, I would say, why do I do this? What is Fuse and what can it do to make your life easier? File systems and user space is really what Fuse stands for. And basically that is using a kernel driver called Fuse to pass what would be normal file system operations into user processes, right? So you get to implement hooks. You implement a bare kind of interface to say how you would handle a file system in your user process, right? Now, I use this. I've used this a couple times. I've worked at Red Hat to do some custom development of custom file systems. I've learned the caveats. Linus Torvalds famously says that a Fuse file system is a toy, and he's 100% right. You don't want to use a file system in Fuse for bulk storage, for block storage. Gluster famously uses a Fuse file system natively, and its performance is awful because they're doing incremental little block reads and writes 4K at a time, and doing kernel mode switches at a rate that makes it impossible to perform. But that means that it's perfect for things like REST APIs, right? So some of the examples we'll see here include vault secrets, Nomad jobs. I've done basic Consul KV. I've not done service catalog yet. I've done TFE and TFC. So you're able to browse your organizations, your workspaces as a file system, right? And the good news is this is tiny, right? So if I go around installing Vault every time I need a CLI, I don't know the last time you checked, but my Vault binary currently is 186 megs. And if I actually list all the binaries in my user bin directory, the HashiCorp binaries, I think 5 or 6 HashiCorp binaries now constitute about 600 megabytes or one REM CD, right? So compact disk worth of binaries is one of the downfalls of having a static Go binary. The good news is it's easy to support, right? If you call HashiCorp with the support issue, we know exactly what libraries, dependencies, and Go imports you're using. So we don't have to troubleshoot your OS and your dynamic libraries. But the bad news, obviously, is things like sidecars and things like tiny CLI agents, right? So I just checked if I do a demo later, my VaultFS statically linked with all of the C++ libraries built in is 300 kilobytes. And dynamically linked, I think is 46 kilobytes. So I'll show you what I've got. I'll show you a little bit of examples. And then further on in the future, an open API adaptation, right? So I've kind of not developed a whole lot on it in the meantime, because essentially what you do to build a Fuse is kind of complicated when it comes to mapping a REST API. And why do I do it? Obviously, I'm biased, and you take a classic Linux flowchart, and the question is it a file? And obviously everything is a file, and there's no reason your vault secrets can't be files, your Nomad jobs can't be files, and you shouldn't have to worry about treating them as such either. So you can just open edit a secret, open edit a Nomad job in the editor of your choice or the script of your choice, and have it immediately take effect. Okay. Now, if you're going to implement a Fuse file system, if you've never implemented one before, there's a couple there's a couple of ways you can implement it. There's minimum requirements, and then there's extended features like being able to fill in extended attributes, and how do I write a symlink, or how do I read a symlink, or write a hard link, or a FIFO. Now, the basics that I cover, the basics that I need that adapt really well to REST API are, CRUD operations: create, read, update, delete. And often those will map to various HTTP verbs. So get, post, put, patch. And unfortunately, one of the prerequisites before any of that is get attribute, right? So if I get attribute on a file system path, I essentially fill a stat buffer. Okay, so what kind of file is it? Is it a directory file, FIFO, symlink? And not only that, but what are the permissions, modification timestamps, etc. And that doesn't exist in a REST API, right? So essentially what I have to do is map the paths requested via a whole bunch of regular expressions. Okay, so this means that not every version will support every version of HashiCorp. There are certain secret engines that I've not added yet to the Vault one, for example. This also means that the REST APIs are usually missing or having an inconsistent list attribute. So for me, CRUD also requires list, and I call it CRUD L, because list is one of the important things of a file system. You can write, ironically, a FUSE file system that implements different parts of this. You can say, I implement how to list a directory, and I can implement how to write a path, which all require get attribute, right? So I can actually have a file system that doesn't implement read directory. So if I go to that directory and list it, there's nothing there. But if I then try to write to something, the read and write update, read, write, update functions inside the FUSE file system will handle it anyway, right? So I can essentially write into a black hole that is being handled on the other side. So it is interesting. You get some of the options to say, okay, list my secrets, and there's no secrets there, but you write one and it magically appears. So you can almost obscure your secrets. One of the other attributes that's really important for this is the security side. And by default in any Linux kernel, or I guess Unix kernel as well, I can't claim the everything as a file system being a Linux attribute. But from a security standpoint, if I mount a vault in a local path or in a Kubernetes sidecar, that isn't a traditional file system that can be accessed by anybody, right? In the kernel default setup, FUSE file systems can only be read or operated on by the user running that process. So not even root. If I spin up and say mount my vault in /mnt/vault, root user cannot even browse that, which is great, because then I know that it's my token being used in that process. It's my secrets, and nobody, not even root, can get access from the outside. Okay, so really handy. Right. But anyway, let me just highlight that readdir is usually the most difficult. Okay, the most difficult to implement. So if I'm running this today, or if I go to the repo later and try to build one of these, I'm going to need a couple of prerequisites. Because I'm not a coder anymore, and most of my coding days consist of C++, and honestly, I still just love it. I'm stuck in my old ways. You're going to need libjson CPP, and you're going to need libcurl. Now, that's enough to build it, right? It makes the code itself a lot easier because we use libcurl, which will use your environment variables for curl proxy and any setup that you would normally have for a curl operation. A little bit different from the Go HTTP engine. Now, one thing though, once you build it, I do have RPMs, by the way, I can share at the end. Once you build it, a lot of people run it and tend to have issues because it actually requires the direct IO option, right? A normal file system, you say mount this option to this path, and then it goes in indirect mode. So it's going to try to cache chunks of 4 kilobyte blocks at a time by default. Now REST API is remote, and there's no way that I can get atr and fetch the length of that response without actually fetching it, right? So I can't just say, okay, this file is 4 kilobytes and then read it, because next time I read it, especially with dynamic secrets, that may change. So I have to turn on direct IO, which means that that FUSE file system is just lying in wait. In fact, it's not doing anything. It's basically a listening service, waiting for those read requests to come in, which it will proxy then on. And so there is no file there. If I do ls in a FUSE file system, one that I've written, there's no file there. It's just a facade, right? It's fake. So providing you guidance to get to what you're actually trying to read or write. Now, everything that I wrote, the Vault FS, Nomad FS, Consul FS, and even the TFE FS use the same environment variable. So if I set my Vault token with the same capital letters and then run Vault FS, it will use my token. Vault address, same thing, okay? And when I run that, typically when I do it, I will do the three main arguments that a FUSE requests. -S for single threaded, because I don't want to have any multi-threaded race conditions. I want to play it safe. -F for foreground. Okay, because if you don't do -F, it will background and you won't be able to control it anymore or view the output. And then -O, which is the normal file system options, direct IO. Okay. If you're debugging as well, if you want to see the actual output and all the curl commands or curl requests that are being issued, you can do a -D. Okay. And it will actually output everything it's trying to find. Typically, the code itself is very minimalist. Again, I try not to write a file that's more than 1,000 lines these days, again, because I'm not a huge coder. The Vault FS one, I think right now is 650 lines. You can read it in about 3 minutes. And Nomad, actually the Open API FS beta that I have, it's not even really a beta yet, I would say alpha, is currently only 450 lines, right? So I try to make it small enough that you can read it at one page and say, oh, I get it. And again, the native ones that I write, so the Vault, Nomad, TFEFS, and here's an example of me browsing my Terraform Cloud organizations, workspaces as file system. And this is Dolphin on KDE. So it'll work with any browser, any CLI tools you've got. Everything in here is using regular expressions. Because if I'm reading a file in, or reading a REST API call really at path organization/org/name/workspaces/workspace name/runs, I actually have to filter that, because in order to do that, in order to do a direct read on, get on my vars, in this example, get my vars from training demo, the file system underlying it will actually have to step all the way through those directories, right? It will have to say, okay, what is workspaces? Oh, it's a directory. I have permissions to it. Okay, what is training demo? Oh, it's a directory too. So all of that has to be filled in line, and that's not always easy. So my regular expressions are often a little bit convoluted. And one thing that I did right off the bat for Terraform Cloud was cache the actual org response, because once you end up getting those attributes over and over, potentially a dozen times a second, and Terraform Cloud is across the planet, that latency adds up, right? So I cache that once. You can actually flush the cache just by touching a file or theoretically doing a signal, process signal if you did that, and that will refresh your cache. But that will help in the meantime, right? One of the things that would be nice to have is, again, the support for indirect IO. But unfortunately for that, you have to read the entire contents of a REST API to get its length and put that in the stat buffer before you can actually read it. So it ends up being redundant. So these are a couple of problems that are actually poised really well to deal with Open API, right? And I'll get into that because Open API essentially is a map of everything that's in the API, and it works perfectly, because then you don't have to sort out with regular expressions what's what. The actual schema will tell you exactly what you need. And now this is a kind of a thrown together example of a Kubernetes sidecar option. What I think is a perfect use case. There is a Docker container out there. I think it might be a little bit old, but it should work for most basic purposes. You can say, add a sidecar to this pod. Ideally, you would have a command being a script saying, use my Kube service account to log in, get my Vault token, and then pass that to the environment where you run Vault FS. Again, with my standard arguments, single threaded, foreground or follow or foreground, and -O direct IO. And then you mount that to wherever you want, right? So in this case, you would obviously have to do a volume mount shared, because obviously in a container, you're not able to share a file system, right? I took this example from an S3 FUSE client. So I can run a sidecar to mount a FUSE file system in another container. So then in your other container below, whatever application you're running, you mount that directory, and then you can simply browse it, just tree mnt/vaultfs or wherever you put it, and get a full stack, a full browsable version of your vault. Okay, to which point you can just use JQ, or just within your application code read that file and get your secret out at runtime, which is great. Okay. Future enhancements before I jump into or try to do a demo. I would love to port to Golang. Again, I do some Golang. I'm not a wizard anymore because I'm not a coder. I posed a challenge to one of our Golang engineers at last year's HEX, who actually did a pretty good job of porting my VaultFS to Go. It was 3 times longer though, and I don't know if that was just coding style or what, but anybody that would love to port some of this to Go, I would aim for the Open API version because it is the future. If all of our products support Open API, then we essentially have one agent that will support everything, and not just HashiCorp stuff, but everything else that implements Open API. So that makes sense, right? You're not going to have a Consul FS agent replace Consul agent, because that obviously has extra functionality around service discovery and the mesh Consul Connect. You're not going to have a Nomad FS do job scheduling, but it will help you basically have a simple front end to the API in a CLI fashion. So you can browse it, you can have auto completion in your shell around the API, which is super straightforward. Okay, I would love to do indirect IO caching, because that way, if you read a secret, go back and read it again, it's ideally still cached in, not just in the FUSE client, but in the kernel cache, right? The file system cache, which makes everything much quicker and is still secure because it's in secure cache in the kernel. It's, I think, a requirement that we do use Open API for that, because there's just too much overhead to try and anticipate a response or a file size with indirect IO. One thing I would also love to add, and I've always thought would be nice, but I've never gotten around to implementing, is Git support, right? So if you implement a handler for /.git and either store it indirectly in another file system or implement it yourself, you can essentially have a file system where you do git clone and it deploys everything for you. It deploys your TF orgs, it deploys your Nomad jobs, and maybe even configures your vault. So there's not just a Git ops in the sense of having a CI/CD pipeline do it, but the actual act of doing a Git clone or Git fetch will update everything for you, which is actually pretty interesting. And fifth, challenges again, now the Hashi side, Open API support. So we added support Open API version 3 to Vault quite a while ago now. I don't know of the progress on the other products right now. I don't think it's there. Terraform Cloud, again, would be nice. Terraform Enterprise, which it would be a pretty straightforward implementation, but I don't know if it's done yet or not. I tried actually throwing this at the AWS S3 repo. It was a little early for that. I don't think it's ready to be put to that stage. One thing that's actually missing from the Open API spec, and I would love, is again, if they added that L. There's no list requirement within Open API. So instead of a tree of paths and descriptions of where to post, where to get, what's the schema for post, what's the schema for get, and what is the command to list, there is no command for list unless you actually implement it on your own, which is, I guess, a superset or not a requirement of the schema. And interestingly enough, the HTTP verb list, which is unofficial and not supported, is also used in a couple of our products. And there's a few open tickets actually about certain Vault secret engines implementing list instead of get, which I really wish it were a consistent standard. Okay. Again, experimental, and this is very, very early stages. I've just kind of threw this together in the last week or two to see if I could have it ready for this talk. It's beautiful in concept, so I can actually do a tree and not just rely on what I've implemented inside Vault FS, which actually omits quite a few of the sys paths and random number generation. The Open API spec provided by Vault is a live spec, right? A live schema. So we'll actually update based on your enabled engines, based on your secrets that you've got listed, and it will list every single path and how to access it within Vault. So again, this is only 400 lines of code. It's enough to describe the entire tree of a vault. I can do basic reads right now. I can do, okay, if it's a get command, use the get URL and fetch it and return it as a file. So you can cat the description of a certain endpoint. And the beauty of this is that certain endpoints, like a secret may have multiple ways to interact, right? So here's a create, there's a way to post, there's a way to patch or put. I can't distinguish that on my side, right? I can't say, okay, well, regular expression, this path is a directory and a file, all right? So sometimes like get secrets is an actual file, but also you post a file to secrets / something, right? That doesn't work in the concept of a file system. You can't have something both be a directory and a file. So the schema is great, and Open API support is great because every endpoint is listed as a directory, and then if there's a post, there's a post endpoint. If there's a put or a delete, there's a delete endpoint. And everything is accessible in a clear way. So what I'm trying to implement, what I actually will implement if I get the time in the next week or so, is if you read a post, or if you open a post, so if I go Visual Studio Code, open restore / post, it will read the schema or template in a new JSON document. And if I save that, write that back out, it will go to the post endpoint, right? So I have instant wizards, I have auto completion. Ideally, if it all works out, haven't implemented it yet, but it makes perfect sense to me, right? So whatever the editor of my choice is, or even if I've got a JSON WYSIWYG tool or JSON editor, I can open a file, start with the template, save, and then it will be written to the API. Now, one thing that is a caveat, again, the APIs use JSON, right? So there is no HCL option unless that comes in the near future. Everything has to be JSON based. So, and in fact, if I do a demo here in a second, I will show you, I think that's it. Oh yeah, I'll show you Vault and Nomad samples. Repo is here. I've also done a Kubernetes one. It's a little bit old. I would like to update it again for OpenAPI, but you drag and drop Kubernetes jobs, or you delete a file, you delete a Kubernetes job. It's pretty nice. The same way the Nomad one works, right? Presentation, again, this is the Reveal.js stack that I use for a lot of my HashiCorp stuff. That's fair game as well. Yeah, pull requests, again, imports welcome. I would love to see someone come back in a month and say, reroute your code in Go, because I just don't, I'm a very old soul at this point, right? Or Go or Rust or whatever you have. I mean, I like to see ideas out there, okay? So let me do this. I'm gonna kill the resolution here because I'm going to reshare it 4K. Sorry, full screen. Any questions in the meantime? I'm not looking at the Discord, sorry, or the YouTube. So, okay, can everybody see this now? Full screen. Okay, great. Now, I've got one tab here running again in the foreground, Vault FS mounted with my Vault Edger and my Vault token. My Vault is actually running on a little nook somewhere in my attic. It's got a CNAME pointed to it so that anywhere on my network I go Vault, it goes up to that. Anywhere I go to a Nomad, I think same, and Consul. I've got CNAMEs for all three going to the same box. And I'm not using TLS because I cheat and I'm developing a lot of crazy stuff. And I'm mostly on a secure network. I don't have anything critical or production grade on here. But you can see all my secrets here in the UI. And if I go over here, I can lsmnt/vault, and I'm going to embiggen this text because it's probably tiny on everybody's screens. So I've got too much going on with these performance monitors as well. lsmnt/vault, again, parallels my secret engines in the UI. So if I need to get something classic, mnt vault, see I got tab completion, I'm in fish shell, bash shell works, same thing. Not Kubernetes. Vault PKI. So this is a class example I use. What's the CA PEM file for my Vault CA, right? All I have to do is cat that or read it from any code I've got. And I didn't have to do the API. I didn't have to memorize the API, and I didn't have to use a binding, right? Ideally, we tell customers you should have a native binding. That is a great goal, but then the binding has to be maintained as well, right? So if the API wrapper has a version mismatch with the Vault or Nomad underneath, and your code has a version mismatch, we get issues, right? So no matter what version your code is, if you can read a file, you can read a Vault secret. And one of the interesting things is if you read a dynamic secret, you cat that secret, it comes out one way. You cat that secret, it comes out another way, right? Every time you read the file, it's different. So you have to be careful. You can't treat it like a normal file. So if I cat ment vault KV, if I try a KV secret test, no, test, sorry, KV1, test 1, sorry, ABCDEF, right? So I can use JQ on that. I can use any tool I want. -r .abc. And I don't have to worry about complicated libraries. Again, this is a 300 kilobyte statically linked library, statically linked binary. And again, root can't read this, right? So it's there, I can read it. It looks like a file, but not even root themselves can read it unless I enable that in the kernel. Okay, now if I look, if I go on the counter and I do a Nomad example, and this is the one that I cheat with on the web page. So I've got one Nomad here again, got one job, which actually isn't presentable, I think, because my my only client right now is an ARM client. This file is the same representation as this presentation. So if I go open with Visual Studio Code, and I've appended the .json here for extensions. That doesn't actually exist in the API. So I can open this with Visual Studio Code. Hopefully you can see this again. Embiggen, I forget how to do that in Visual. There we go. So if I want to edit this, in fact, if I do a stop true, and the second I save this file, you'll watch over here, it's dead, right? So edited text here, as soon as I save, takes effect over in my Nomad cluster. And if I do something invalid, if I break it, like this isn't a Boolean, and I save it, it's going to be an error, right? Failed to save. So I can't step on my own foot. So it'll restore that. And I actually have to return an IO error. Like, oh, I couldn't, this REST response returned an error. It doesn't matter what error it is. All I can do in the file system is say IO error, could not write. Okay. So the great news is if I use JSON schemas here, I can throw everything together for a Nomad job. Again, I can't use HCL yet. I would love the API to support that at some point. Okay. Now, I'm looking at time. Okay, 5 minutes. I'm going to give some time for questions, but anybody that wants to browse the code, again, pretty straightforward C, C++. It is a little sloppy, right? I am not a production engineer for HashiCorp. This is just a bit of fun. But anything, give it a test drive. Single file, single compile, as long as you have the dependencies, is ready to go. Oh, and there's RPMs. I use Copper. HashiCorp. There's a Copper repo, which is Fedora's packaging and CI/CD system. Packages. So there's RPMs for Consul FS, Kubernetes FS, Nomad FS, TFE FS. I've not added OpenAPI FS yet. If you go to the repo, this is brand new. So literally yesterday, I committed this. And it still says TFE address, so I still have some copy pasta in there. But now, if you look at it, it's straightforward. All I do so far is the read dir. So I implement a read dir command. All you have to do is implement this hook. That steps through the schema paths, if you've downloaded the Vault OpenAPI schema from your Vault before. And then I find the path indicated by what I'm trying to read. Okay. So there is a little bit of fudging here for the types again, because it is just straight paths. I have to kind of account for what's a directory and what's a file. But OpenAPI makes it a lot more straightforward. And I'll stop right now. Any questions? Got about 4 minutes.
Really terrific. And I'm kind of blown away at the amount of detail that you've put into this and how actually well, I don't mean like badly, how well it works. That sounds terrible to me. I mean, well, like there's a huge amount of effort. I mean, it's like I think you mentioned it like flippantly, sort of, it was about 800 lines of code or something like. Yeah, 800 lines of very, very complicated code.
Yeah, well, yeah, a little bit. If I go to regular expressions down here, this is funny because literally Vault, Vault has the capabilities endpoint. Like, okay, what's the capabilities on this path? And you'd think that would be simple enough to figure out what's what, but no, you still have to do regular expressions everywhere.
We have
So,
a question around well, so it's around the sort of the PKI and the dynamic certificates. Could you kind of showed how you can obtain a dynamic certificate just by sort of from the file system, but could you actually also create like a symlink to a HashiFUSE
yeah,
HashiFUSE
yeah. So,
path?
interestingly enough, yes. So symlinks are just text, actually. In fact, first time I had to implement a symlink in Fuse, which is in one of the extra hooks. I'm like, oh, I'm gonna have to figure out the signs of symlinks. It's like all a symlink is a string. What's the actual path I'm trying to go to, and you set its stat type to symlink. So if you symlink, okay, mnt/vault/pki/ca.pem or whatever the path was into your etc pki directory, that will be a local file
Yeah,
on your other file system that is a text to point to that path, and that will work. If the file system goes down or there's an error and then you try to access it, it will be an error because there's
yeah.
nothing there. But yeah, symlinks will work fine. One thing
Wow.
you
So
can't do is put a symlink into VaultFS or
right.
into, okay,
Very, very cool.
great, great.
Uh, oh, sorry, I was just checking the chat for any other questions. But the nice thing, I love the fact that you're kind of actively maintaining as well. I mean, it's
Well,
pretty cool to see the
I got it as far as I could use it in probably a year ago, and
yeah,
VaultFS was fun. And there's a few new secret engines that need to be updated. And we talk about plugins. We've seen a few plugins today in Hashi talks. And, as is, it doesn't handle plugins unless you use OpenAPI, which is one reason I need to actually flesh out the rest of OpenAPI.
I think it's a wonderful system. And yeah, please, the YouTube chat is you can kind of like hang out for
Sure,
the
sure.
because